Hi, this is Anita Rana, and today we are going to start with the chapter Electricity of class 10th. And today's topic is resistance of a system of resistors in series and in parallel. So, before starting with the video, do like and share the video and subscribe if you want some more. Resistance of a system of conductor. Conductors or resistors can be connected with one another in three ways: in series, in parallel, in series parallel combination. Resistors in series combination. Today we are going to start with resistors in series combination, that how they are connected. Let us see this diagram or a connection in which the three resistors R1, R2 and R3 are connected in series with a voltage. Now, what is the total in this? That the net resistance of the combination is equal to the sum of the resistance of the individual conductor. अगर आपको total resistance निकालना है तो we will find that this is the simple mathematical addition. So Rs is equal to R1 plus R2 plus R3. I will explain you this with the numerical values in this video only. The second point regarding the series connection is that the current flowing through each conductor is the same. Means the amount of current that is flowing in one resistor is the same as it will flow in the second resistor. And the third is that the voltage applied across the series combination of conductor is equal to the sum of the potential difference across the इंडिविजुअल कंडक्टर. मतलब यहाँ पे जब हमने देखा था ना, ये R1 में जो वोल्टेज है वो V1 था, R2 में यहाँ से यहाँ के बीच में जो वोल्टेज है वो V2 है, यहाँ पे R3 के लिए द वोल्टेज इज V3. So the total connection is means total voltage applied is V is equal to potential difference for resistor 1 plus potential difference for resistor 2 plus potential difference for resistor 3. According to Ohm's law, V1 is equal to IR1, यानी कि हमारे पास V is equal to IR होता है, तो V1 is equal to IR1 and V2 is equal to IR2, V3 is equal to IR3. Now what we have to do, that if we have to find out the Ohm's law, means the various values using Ohm's law, then we will do this. Total potential difference across is equal to IR1, means amount of current flowing through the resistor R1 plus IR2 plus IR3. इसको हम I को बाहर निकालेंगे तो R1 plus R2 plus R3 we are having and V is equal to IRS. See बच्चा, when this is R1 plus R2 plus R3 we write it like, so we always give the term RS, means resistance in series. So let us take an example to know how to calculate the resistance, current and potential difference in a series combination. Suppose again the same diagram that we did earlier, circuit diagram. Now we have given the values for this. R1 is equal to 1 ohm, R2 is equal to 2 ohm and R3 is equal to 3 ohms. A voltage of 6 volt is supplied to this. Now every resistance have their own voltage, but the current flow is the same. So how we will find out the total resistance? The total resistance is equal to Rs is equal to R1 plus R2 plus R3. Substituting the values in the Rs, we will get 1 plus 2 plus 3 is equal to 6 ohms. So according to Ohm's law, we have to find out V is equal to IR. Current now we have to find, so I is equal to V upon R. We calculated I is equal to 6 and we have already V is equal, R is 6. So I is 1 ohm, means a total of 1 ohm current will pass through the circuit. Now potential difference, as I told you that potential difference in a series combination is different or is according to the resistance. So V1 is equal to IR1, I की वैल्यू 1 है, R1 वैल्यू इज़ 1, so the voltage across the first R means resistance 1 is 1 volt, and same way we will calculate for the V2 and V3. Now total PD is equal to V is equal to V1 plus V2 plus V3, substituting the values. V is equal to 6 ohms. If you see the diagram, we have already given that the voltage difference across this is 6 volt. So this 6 volt and this 6 volt values are already given and they are satisfied. Now along with this, I would like to discuss with you that what are the disadvantages of series combination. What are the disadvantages of series combination? In series connection, there is only a single path for the flow of current, as I told you. But if any of the appliances fuse or break, the current will not pass to another appliance, and hence it will also not work. So physical means this series combination is not allowed in the domestic circuits. And the second disadvantage of this is that every appliances connected in series require different amount of electric current for their working. Hence, being in series, it's not possible to meet with the requirement or with the required amount of the current, hence will not work properly. We will study about the resistors connected in parallel. Now when in a connection, the resistors are connected in parallel, how they are connected? This you can see is a circuit diagram that shows that the three resistance R1, R2 and R3, they are in parallel to each other. The amount of current flowing through this is different for different resistors. For R1 it is I1, for R2 it is I2, and for R3 it is I3. Whereas the voltage that is supplied for these connection is always the constant. Let us study this later. The net resistance or equivalent resistor. Now how we can find out the net resistance or equivalent resistor? So this we can find out by the reciprocal, by the addition of the reciprocals of the all the resistance, like 1 upon Rp means reciprocal of resistance in parallel is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now what we have to do, we have to take LCM of R1, R2 and R3, and after taking the LCM we will get R1, R2, R3 and R2, R3 plus R1, R3 plus R1, R2. So this is equal to 1 upon Rp means resistance in. Now look forward, if we have to find out Rp, what we will do? We will simply reciprocate it again, and 1 upon Rp is equal to R1, R2, R3 upon R2, R3 plus R1, R3 plus R1, R2. So hence from here we concluded that the total resistance Rp is equal to the reciprocal of the net or equivalent resistance of the combination. Now different amount of current flows through different resistors that I told you earlier, and the potential difference that flows across the two ends of the parallel conductor or combination of the conductor is always equal to the voltage applied. Now how to calculate the resistance? Let us take an example to learn how to calculate the resistance in parallel series in parallel connection. So here again the same diagram. Here we have given R1 is equal to 2 ohm, R2 is equal to 3 ohms and R3 is equal to 6 ohm, whereas the PD across the conductor is 8 volt. Now how to calculate? Total resistance is equal to reciprocals of the sum of these. So we will substitute the values and we will get Rp is equal to 2 into 3 into 6. From where I get this? I get this from here. right? RP के लिए I use this formula and I substituted the values and this formula and I get this 36 upon 36 is equal to RP is equal to 1 ohm. So total current flowing through each resistors, how we will calculate. So V is equal to IR. Use this formula. V is equal to IR. V is equal to I1 R1 and V upon R1 is equal to I1. To substitute the value, I1 is equal to V is 8 and R1 is 2. So 4 ampere. I2 is equal to 8 upon 3 is equal to 2.66 ampere and I3 is equal to 8 by 6 is equal to 1.33 ampere. So total current flowing through this is equal to I is equal to I1 plus I2 plus I3. So we substituted the value and we got I is equal to 7.99 ampere approximately. Because here when we were calculating this 8 by 3 we got 2.66 and 6 is a recurring, means again and again it was coming, so it is approximately 2.67. so from here we get the value 7.99 approximately, or it may be 8 ampere. Clear to all? So this is all about how we can calculate the resistance, total resistance and current when the resistors are connected in series. Thank you.